good day, and welcome to Africa Teen Geek. This is STEM Digital School. If you have just joined in, my name is Nonkulego Matondo, and I am your Physical Sciences Grade 11 teacher. I'm just having quite a glitch with a slow network, but nonetheless, I'm happy that everybody was able to join in today. Oh, yes, here we are. I am Nonkulilego Matondo. I am your teacher for grade 11 physical sciences. Today it is the 28th of July 2020, and we are continuing with our work. Oh, it seems like this chapter is actually bigger than we actually expected. If you remember, earlier on we started with all the theory parts, and thereafter we came to do the calculation, except for the electromagnets. The electromagnetic part doesn't have calculations, so we did not make calculations for that. So you also make sure that you make a note there that there is no calculations for electromagnetism. So here we've been doing the electric circuits for the past few days, and we had our assessment last week, and we did our corrections, which we finished off yesterday. I hope that everybody got it right, and they now slowly understand what is going on with electricity and magnetism. Nonetheless, um, today, as you know, yesterday we were not done with the whole chapter, even though we had assessments, but we only had assessments up until where we ended our work. But I told you guys that we still have at least two parts, two units that we still had to do, which was the series parallel circuits, and it's also the electric power. So we still have to do that. But today, I think we're going to be doing the exercises with regards to the electrical circuits, because I think once we do this, it will be sort of like revision for the electricity part of the work. And once we go and do revision, because soon we're also going to be starting with revision after we do our term 4, we're going to be doing the revision for the whole year. So if you have a lot of problems that you have done already, then it's not going to be so difficult, because it's going to be things that you understand and things that we have practiced together. Okay, reminding you guys as well that we work here from the Oxford Successful textbooks most of the time, but you can also use the Siavula or the Study and Master, or any other CAPS approved textbook is allowed into this classroom. So if you have any, you can just use that and go to the specified chapter that you're working with, and you'll still be able to follow through. And another thing that I wanted to let you guys know is that in this classroom, if you have any problem whatsoever while I'm teaching, you don't have to stop and be afraid. You can just go to the chat and ask your questions so that I can deal with it at that very moment. Okay, so make sure you do not die alone. The aim of this classroom, I always remind you guys that it's for you guys to learn and understand. If it means that we have to be stuck in one problem because you guys don't understand, then we'll do that and continue tomorrow, because the most important part is for you guys to understand physical sciences for grade 11 and understand how to apply the problem and concepts all in one together. Okay, so you can get Snaplify. Snaplify is an application where you can get all your textbooks. That's where I got all my textbooks. So it's made absolutely free until the 31st of December 2020 because of the COVID-19 issues. So they've been gracious to us and given us Snaplify textbooks for free. So if you feel like, not just for physical science, for all your other subjects, if you feel like there is some information that you would like to know, or you've got some textbook that you want to read through, then you can do it on Snaplify. Okay, yeah, so let's get on. So there's a couple of homework. I remember, guys, I gave you guys homework, but this homework is a lot of work. So I want us to just go through it. So which means that while I'm going through it, you will also be going through it on your side, and you can follow through the series parallel problem. Okay, because I know that sometimes they can take a lot of time doing these problems, but I'd like us to do them as a practice in order for us to know what is going on. Okay, so let's start with number 1. I hope that you guys have done it. To make it easy for you guys, wherever you get stuck or where you're getting wrong answers, to ask questions. Why is this one wrong, or why did you choose R1 or R2, etc. Okay, so let's start with number 1. Number 1 says, refer to the following circuit on figure 5, which is this circuit right here, right? So they say for 1.1, calculate the total resistance of the circuit. So what do we know about calculating the total resistance of the circuit? We know that we've got a series branch here and we've got a parallel branch here. But what we need to do, we need to get an equivalent resistance. An equivalent resistance is the one that's gonna show us the total resistance. And remember, when we did our steps on how to calculate a series parallel circuit, what we first need to calculate, we need to calculate the parallel branch, because the parallel branch is much more complicated. So we start with the parallel branch where we say R parallel is equals to 6 times 9 divided by 6 plus 9. Okay, that's going to be our R parallel. That's going to be our parallel branch. And then once we have this parallel branch in series, now we've got two series resistors. And what do we know about series? Our series is going to be R parallel plus R 2.4 ohms. Okay, then from there, now we're going to have a single block called the equivalent resistance, which is a representative of both branches added together. Okay, and you can even draw that. Okay, so let's see how we calculated that. Okay, here we are. So first, we list the variable. So you see the circuit diagram, and then you select an equation, which in this case is going to be the 1 over R parallel is equals to 1 over 6 plus 1 over 9. But now you can switch them. Once you substitute your values, remember we try and make it a common denominator. That's why I just said for R parallel it's going to be equals to 6 times 4, 6 times 9 divided by 6 plus 9. But in this case, we chose 6 plus 4 because we got the lowest common denominator as number 30, and that's where we had it. And when we add it together, we swapped it. You see here, it was interchanged. Here it's supposed to be 10, sorry. This is a 10. This one here is supposed to be a 10. So that's just a small error, but you can just ignore the error. It's supposed to be a 10. Okay. And then you get your R parallel. You just swap them around, the 1 over RP, and you swap these ones around as well to get your R parallel as the subject of the formula. Okay, so now we've got our R parallel. We move to step 2. On step 2, now we're going to have the sum of the series resistances. So because remember now that you have made one parallel branch, now you have these both in series. So now you can add them together to get your equivalent resistance. Okay, so there you have it. Your equivalent resistance in the circuit will be 6 ohms, because now you've added them together. Now you have only one equivalent resistance that represents the whole resistance of the whole circuit. I hope that this makes sense to you guys and you understand. If you don't, however, your time to ask is now. Okay, so number 1.2 says they want to know the reading on the ammeter. This is our ammeter here. Guys, I cannot stress it enough. The ammeter does not put current in the circuit. The current is induced through this battery, right? There's current there that's getting induced and it's flowing in the circuit. So these are the conductors, these are the wiring that are transporting the current. So when we put an ammeter here in series, we're just basically using an instrument to see how much current is flowing. It has no influence in the current flow. It has no influence in any flow. All it does, it's just a measuring instrument. So now they'd like to know the reading on the ammeter. So let's go and check how much is the current. Okay. So on 1.2, so we list our variables. We've got our voltage, which is 15 volts, which is the potential difference through the circuit. And we've got our equivalent resistance. So in this case, because they want for the whole circuit, we use the equivalent resistance current, right? Because it's for the whole circuit. So what is our I? Going back to our Ohm's law, remember our Ohm's law, I is equals to V over R. When we interchange using the triangles, remember the triangles that I showed you guys yesterday, that they are very applicable into this chapter. Then we're going to have our V is equals to IR, and we're looking for I. Then you make I the subject of the formula, be 15 divided by 6, and that's going to be 2.5 amps. So the reading on the ammeter is 2.5 amps. Okay, so that is that for 1.2. So now they'd like to know as well, 1.3, what is the reading on voltmeter 1? As you can see here, you see how the difference on how you place your instrument. The voltmeter is also an instrument device. It's only interpreting how much voltage is there across these resistors. It doesn't have any influence into putting current or changing the voltage. It's merely just a mirror image of the value of voltage that is flowing. It detects the voltage that flows in this resistor. So I want you guys to also note that an ammeter, when you have an ammeter in your circuit, you always connect it in series. But if you have a voltmeter must always be in parallel to whatever you are measuring. Okay, so make sure that even when you do experiments later on, you do not forget this, because if you put your voltmeter in series, your voltage is going to be 0. If you put your ammeter in parallel, your current is going to be counted as 0. So those are important things that you also should take note of. Okay, so now we're looking for voltmeter 1. Okay, so we need to calculate what is the current that is flowing on this voltmeter. Okay, so let's do that. So we're going to list what we have. Okay, first we have the resistance of the resistance, which is R1, that is already given, and we know that the current flowing in the whole circuit is 2.5 amps. How do we know that it's 2.5 amps, guys? We know it's 2.5 amps because it's in series here. Remember, in series it's a voltage divider, so the current there flowing into this branch is also going to be, so if there was an arrow here, it will show that what's going in here is a 2.5 amps, but it splits here, but when it gets here, it becomes whole again, and what flows here is the same current that you measured over there, which is the 2.5 amps, right? So you're going to use this current times this resistance. That will give you the V1. Okay, I hope you guys are good and you understand what. If you don't, guys, please make sure you send me a chat and I'll go back and explain. So you see, this is the current that's flowing in the whole circuit. Current is 2.5 amps, and it's the same in when something is connected in series, but it's only split when there's a parallel branch. But in this case, because it's 2.5, we're going to take it the way it is, and we've got our resistance, and we substitute now using our triangle. Remember our triangle of V over IR. So voltage is equals to current times resistance, and that will give us our 6 volt. Okay, there it is. This is our 6 volt. So for V1, we've got 6 volts. So continuing there, it says now, what's the reading on voltmeter 2? Okay, so this one is simple, guys. How are we going to find that? This is the total voltage that's here, and here we've already calculated 6 volts. So which means that because here you are calculating for the whole parallel branch, it means that our voltage, our total voltage is equals to V1 plus V2. So if we're looking for V2, it's going to be V2 is equals to V minus V1. So it's going to be 15 minus 6. So it should roughly be 7 volts. Okay. So you see, once you have one, you can calculate the other one. Okay. So let's go and see. Okay. I do not have it here. 1.4. I think I forgot to add the 1.4. But you guys, I'm sure you understand what I mean here. You're just gonna say 50 minus 6 will give you voltage here. So it's gonna be 7 volts. Okay. And then you move to current in the 9 ohms resistance. Okay, so in the 9 ohms resistor, first we need to calculate the voltage. We know the voltage in this branch is 7 volts. So if remember, voltage is the same. So if the voltage V2 is 7 volts, it means that this one is going to have 7 volts, and that one is also going to have 7 volts. So if you want to find the current, we're going to say current is equals to voltage divided by resistance. And our voltage in this case is going to be 7 volts divided by the 9 ohms. And there we're going to have ourselves the current. Okay, you guys understand? We always work. Don't forget, guys, when does voltage divide? When does current divide? Those are important things that you always have to bear in mind in your condition, so that you know that you don't have to find something unnecessary. Because sometimes, for example, you can make a mistake thinking that oh, this voltage somehow here it's divided. No, it's not divided because it's in parallel, and this is a parallel branch. So it's the same voltage, but you divided by whatever that you require here. Okay, are we good to go? Any questions? Okay, so let's move on. It says on number 2, refer to figure 6, which is this figure right here. Use the information on the circuit diagram to calculate the following. So here we can see we've got our source, our battery, and the voltage. This is our terminal voltage. It's 12 volts. And then we've got our parallel branch there, and we've got our series branch there. Okay. So you see how they wrote it. Here they put the 12 volts here, but there they just wrote it there in front of the battery. So these are similar ways, but placed in different forms. Okay. Even the arrangement here, you can see here it's a parallel branch and a series branch. So that this one they put it on the side, but at the end of the day, it means one thing. Okay. Okay. No, I will do that. I will send you guys the questions, but where should I send the questions? Okay. You know what? I'll give you guys my email so that you guys can be able to see the problems as well. Okay. You'll see my email. I'll leave it at the end of the lesson so that you guys can, once you guys send me an email address, I'm going to give you my email address, and then you guys can just email me, and then I will attach the problems to you guys. Okay. So can we do it like that? All good. You send me an email. I'll show you the email address at the end of the lesson. And thereafter, you guys can send me an email, and I will send you guys the questions and the problems. Okay. Unfortunately, I won't be able to write an email address right now as I'm teaching the lesson, but please make sure I'm going to show you my email at the end of the lesson, and you can take that email and send me an email, and I will attach all the problems. Okay, are we good to go? Yes. So now we've got this one. We've got on question 2, we've got a similar arrangement as this one over here, but it's just placed in different ways. Okay, we don't have a voltmeter there, and we don't have an ammeter that's placed there. What we have is the terminal voltage, and obviously here the stuff that we're going to be looking for. So on number 2.1, it says they want the total current in the circuit. So guys, whether they ask you to calculate the equivalent resistance or not, what you guys need to know is that once they ask for total current or they ask for the total voltage, you just have to calculate and make it an equivalent resistance. So because they told us that we need to calculate the total current in this thing, we've got our voltage, which is 12. But now for our resistance side, it means that we need to have an equivalent resistance in order for us to have our R part, so that we can have I is equals to V over R. So the R is always, once they say the total, you know that we need to use an equivalent resistance. So what we're going to do first, we're first going to calculate this parallel branch. And we know that for the parallel branch, it's always 1 over R parallel is equals to 1 over 1 ohms plus 1 over 4 kilo ohms, okay? But here it would be 1,000 and 4,000, sorry, because it's kilo ohms. And thereafter, we make it an equivalent circuit. Once we get our parallel, then it's going to be R parallel. Then we're going to add it to the 1,200 kilo ohms. And this addition of 2 will give us our equivalent resistor. Okay. Then once we have our equivalent resistance, now we can multiply it with the V to get our total current. Okay, let's just go see it properly. Okay, so here we have it. So first you need to calculate part 1. You need to calculate the equivalent resistance of the parallel resistors. And that's where we have it, like I mentioned to you guys. It's going to be 1 over R parallel is equals to 1 over 1,000 ohms plus 1 over 4,000 ohms. And this will give us our R parallel. So here we make this the subject of the formula. I mean, the lowest common denominator is 4. And here you times it by 4. It's going to be 4 plus 1. Okay, so it's going to be 4 plus 1 and 5. And then we're going to swap it around. And it's going to give us 0.8 kilo ohms. Okay, so now that you've got the resistance for the parallel branch, we can add it to the 1.2 kilo ohms resistor, right? And that will give us 2 kilo ohms. So which means that now we have our equivalent resistance. So after we have our equivalent resistance, now only can we go and calculate our current of the whole circuit. Okay. So here it is now. Now we can calculate the total current in the circuit. So this will be, we know for the potential difference or terminal voltage is going to be 12. And this is what we have. So now we find the current. So the current in this case is going to be 6 times 6 milliamps, or 6 times 10 to the power of minus 3 amps. Guys, this is your chance to ask. If you're getting stuck anyway, just let me know so that I can explain. But this is how we get this part of the question. Okay. Okay, so there we have it. So now we are moving on to the next question, which is number 3.2. So you see, it's just a small question. It says calculate the total current in the circuit, but you wouldn't imagine that you still have to first calculate the resistance and calculate this and this. So you need to always be aware, and that's why they always say practice makes perfect, because the more you practice the work, the easier it becomes for you to understand and to see any trick or any unhidden details that is not there. So let's move on to number 2.2. It says the voltage or the potential difference across the 4 ohm resistance. Let's look for the 4 ohms resistance. There is our 4 ohms resistance. So our 4 ohms resistance, the first thing that we have to do, right? What are we looking for? The potential difference. So what we're going to look for here, first, what we can do, basically, we can find the voltage for this one, right? If we find the voltage for this one, we're going to say voltage equals to current. The current, we already have it. We already have the current, right? I think it's 0.8, oh, it's 6 milliamps, right? So you're going to say, you're going to find the current for here. You're going to take it and look for the voltage. So voltage is going to be equal to I times R. So once you have the voltage here, you go back and you say voltage total is equals to V1, V series plus V parallel. And once you calculate those together, you'll see now we're going to make V parallel the subject of the formula. So it's going to be the V is going to be the 12 volt minus the voltage that we got here. So that's going to be the voltage here, because the voltage on your 4 kilo amps is the same as the voltage on your 1 kilo amps. Why? Remember what we said about this one, is that it's a A parallel branch is a current divider, but the voltages are the same. So V is the same in both the parallel branches. But in the series branch, then it divides. That's where the current is the same. That's why we're using this one, because we have the current that is in the entire circuit and it's also in series with this one. So the current is the same. So that's why we took this one to calculate the current, and thereafter we can find the voltage, which is we can use to find this voltage here. But okay, let me just show you guys how that gets to be done. Okay. Okay, so this is what we do first, right? So we're going to our V, we're looking for the V across our parallel branch, right? So step two, we select an equation, which is V is equals to I times R, which is going to be the 6, which is the current, plus times the 0.8, which is the parallel branch. And that's going to give us 4.8 volts. Okay. So when we simplify that, our V is going to be equals to 4.8. So in this case, they calculated it directly, right? They just calculated our R parallel, and the R from R parallel, they said R parallel times the current, and that will give us 4.8. But either way, it would give you the same answer. Remember, guys, there's always many ways to kill the cat. But if you feel like, for example, you're not sure if your parallel branch you got the correct amount of ohms, you can do the same procedure. You can calculate the voltage on the series branch that was given, and from there you can just say V total is equals to V series plus V parallel, and you make V parallel the subject of the formula, and you will find your voltage across your 4 kilo ohms resistor. Okay, so you see how it's done. If you guys are getting stuck, guys, please don't hesitate. Just send a chat and we can see how we can work this out. Okay. So now we're moving on. Now they want to know, okay, we've done this number 2.3 now. Now we're moving to a more complex circuit on number 3. So now they say the following question refers to this figure right here, which is our figure 7. So in this case now, we've got 3 branches. It's not the same as before when we just worked with 2. So it says here, calculate the current in the series section of the circuit. Which one is the series section of the circuit, guys? It's this one. This is our series circuit of the branch, okay? So how are we going to do this? So to calculate the current in series, we're going to say voltage times current, and our current times voltage. Current is equals to voltage divided by resistance, and from there we can get what goes into this one here. Okay, so let's go and check it out in words. Here we are. So first of all, we apparently here we need to calculate the equivalent resistance of the parallel branch. Okay, why are we calculating the resistance of the parallel branch? Because we're looking for the current in the total system. Why are we looking for the current in the total system? Because whatever current is flowing in the whole circuit is also the same current that is flowing on your series branch, because they are the same, right? So what we do first, we calculate, we convert it to an equivalent resistance. And to do that, we're going to start with the parallel branch. We always start with the parallel branch because it's always the most complicated one. So we come here, say 1 over R parallel is equals to 1 over R1 plus 1 over R2 plus 1 over R3. So our 1 over R parallel, in this case, we're going to find the lowest common denominator. And in this case, it's going to be our 12. So if 12 is our lowest common denominator, here it's going to be a 3, here it's going to be a 4, and here it's going to be a 1. And you add them up because now they have a common denominator. And therefore, after that, you swap them around to get your R parallel as the subject of the formula. So that's going to be 12 divided by 8, and that is going to give us 1.5 ohms. So now we're done with the parallel branch. Now we move to the series branch. Now we need to add them together to get our equivalent resistance. Why are we looking for equivalent resistance? So that we can get our current that's flowing in the circuit. Why do we need the current that's flowing in the circuit? So that we can find the current that's flowing in the series branch. Because in series, current is the same as the total current. Okay. So here our equivalent resistance is going to be 2 ohms. Then once we have our 2 ohms, we've got our potential difference, which is a 10, and we've got our resistance, which is a. Now we can find the current. So the current in the series branch and the current in the whole circuit is going to be our 5 amperes, which is the one that's over here. Do you guys follow? Do you guys understand? Is there something that you'd like me to clarify? Please let me know, be it the series or the parallel conditions. I will do that. Okay. Okay. So we move on now. So now they want to know, calculate the voltage across the resistors in parallel. Okay. So they want the voltage across the resistors in parallel. So we already have our R parallel, right? So what are we going to do? We're going to, if we have our resistors in parallel, then we can find the current. RP is equals to current times. But if, remember guys, if this is R parallel, it's one block here. These two are going to be in series to one another. Remember, now we've got an equivalent for the parallel, which is R parallel branch. So our R parallel, which means our current will flow this side, and it will come to this part, our series branch, and it will also come to the parallel branch. So which means that the current is still the same for the parallel branch. The only time it's going to split is if they want, for example, the individual currents inside this parallel branch. For example, if they ask for the 4 ohms or the 3 ohms current, that's only when we will have to have a split of current. But if they want it for the whole branch, then we can use the total current that we've just calculated now, and we divide it by, we're going to take the voltage and we divide it by the current. So let's go there. It says calculate the current, the voltage across the resistors in parallel. So it's going to be the current that we just calculated, the total current, divide that by the R parallel, which we have already calculated when we were doing our equivalent resistance. So let's just go there. Okay, so here it is. As you guys can see, we've got our R parallel that we calculated over here. Remember, we got our R parallel here when we started doing the equivalent resistance. And then we've got our current, which is the one that's flowing. That's the one that we calculated here, is the current that's flowing in the whole circuit. So now we select an equation, which we're looking for the V. So the V is equals to I times R, which is going to be the 5 amp times the 1.5 ohm, and that is going to give us 7.5 volts. Okay. I hope that this all makes sense to you guys. Okay. So now, what they want to know the current that's flowing in the 3 ohms resistor, which is this one here. They want to know the current that is flowing on this 3 ohm resistor. Okay. So to find that current, we're going to use the voltage, which is the voltage of the R parallel, which is already given to us. So we're going to say current is equals to V over R. The voltage is the same in the whole parallel branch, so it's going to be 7.5 volts, and the resistance is the 3 ohm resistance that they spoke about. And from there, we're going to get our current as 2.5 amps. So the current through our 3 ohm resistor is 2.5 amps. Okay, getting lost? Please don't hesitate. Just send me a chat and I'll make a point to send it to you. Okay. So 3.4.1. 3.4.1, they ask here, explain which resistor in the circuit has the number one, highest current through it, and number two, the lowest current through it. Okay, so which resistor in the circuit has the highest current and which one has the lowest current? So number 4.1, the one where we say we're looking for the resistor with the highest current is going to be the 0.5 ohm resistor, carries the highest as it is in the series part of the circuit and all the current passes through it. Remember guys, in series, current flows completely. So I total is equals to I1 is equals to I2. But once it gets to a parallel branch, then it divides. It becomes I total becomes I1 plus I2 plus I3. So you see, once it divides, that's why in series it's a current divider. In series it's a voltage divider, but in parallel it's a current divider. So the highest voltage will obviously be in your series branch because it's not dividing the current. The whole current, total current is flowing through it. It's only going to start being the lowest once it gets to the parallel branch, because on the parallel branch it has to split up between the three resistors that are flowing there. So the 12 ohms resistor carries the lowest current. Why? It is the biggest resistor in the parallel connection where the current splits up. So it will obviously have the lowest. Why does it have the lowest if the resistance is high? Because the resistance, guys, the resistance is indirectly proportional to the current flow. So the higher the current, the lower the resistance. The lower the resistance, the higher the current. As you can see, here's our parallel branch. Okay. Our equation is current is equals to V over R. But for us to increase or decrease the current, we can control it using the resistors, right? So when our resistance increases, our current decreases. So which means that our lowest current will be the one with the highest resistance. In this case, it's going to be the 12 ohms because it's the highest resistance out of all of them, and therefore because it's indirectly proportional to the current flow, it means that the highest one will give us the lowest current. Remember guys, resistance limits the current flow. So the higher the resistance becomes, the lower the current is. Okay. I hope that makes sense to you guys. So now let's move to number 4. Number 4 says, calculate the following information about the circuit in figure 8. Okay. So here we have it. This is our figure 8. Yo, do you guys see what's happening there? This one is getting a bit tricky, but let's work. So here we've got our ammeter. The ammeter here it's calculating the total current, and the voltmeter here is calculating the terminal voltage, which is our 10 volts. And here we've got our R is equals to 140 ohm, but they've given us the voltage that is read across it. Okay, you guys see? And then here, now we've got a parallel branch. So our parallel branch, the resistor 1, which is 600 ohms, and we've got resistor X, which is not given as to what it is. So we're obviously going to have to look for it. Okay. So now what they want to know is the current on the ammeter. Okay. They want the current on the ammeter. So you see, Here we've got our terminal voltage. We've got our voltage. So on our ammeter in this case, we're going to have to find the voltage here, right? How are we going to find the voltage here? Our voltage here is going to be voltage with X is equals to 10 minus 2.8 volts, right? So there we're going to have now our voltage for all of them. And when you're want the reading from the ammeter, now we can say the voltage divided by the resistance, and we need to find the equivalent resistance. So let's go and see how that can be done. Okay. Okay. We only have a few minutes left, guys. But I think that we'll probably try and do these problems. We're going to try and do these problems again and finish them tomorrow. But for now, let's just do this problem. Let's do number 4.1, which says it wants the reading on the ammeter. So let's check the reading on the ammeter. Okay. So the reading on the ammeter is the same as through the current flowing through the 140 ohm resistor. Okay. So step one, we're going to have our voltage across the 140 ohm resistor and the resistance, which is 140. So I just want to show you guys something. There we have it here. Do you see what's happening here? Remember we said any resistor that's connected in series will have the total current. So if you want the total current, because this one is a series branch and we've been given the voltage and the, it means that we can find our current, and our current in this case is going to be voltage divided by the ohms, okay? The resistance, voltage divided by resistance. So once we have the current here, it means that we have the reading on the ammeter because it's in series and it can give us the same answers, okay? So there we have it. Current is 0.02 amps because it's the current that's flowing in series and it's the total current in the whole circuit, okay? So 4.2, they want to know what is the voltage across the parallel connection. Okay, this one is much more simpler. Remember what I told you guys is that we can find this voltage here if you've got these two voltages, because the total voltage V terminal is equals to V1 plus V parallel, Vs plus V parallel. So what are we going to do? To look for V parallel, we're going to say 10 minus 2.8, okay? And that's going to give us 7.2 volts, right? So which means this parallel branch has 7.2 volts current running through it. Okay, so here you see it. This one is very simple, especially if they've given you so much information, you can be able to find what is missing. Okay, so now they want the current in the 600 ohm resistance. They want the current that is flowing here. Okay, so to look for the current here, we've got the voltage, right? Remember our voltage is 7.2 and this is a parallel branch. So the voltage is the same between both branches. So what are we going to say? We're going to say voltage current is equals to voltage divided by resistance, which will be the 7.2 volts divided by the 6 that we need. Okay, let me just rush through fast and let's see how they found the resistance of resistor X. For resistor X, V is equals to 7.2, right? And we've got our current there as well. So we're looking for Rx. R will give us, will be V divided by I, which will be 7.2 divided by 8 times 10 to the power of minus 3. So this one x will give us 900 ohms. Okay, so our Rx is going to be 900 ohms. Guys, I think we have reached the end of our lesson. We will do number 5 tomorrow before we move on to our next exercise. But I see that the time is up. My name is Nonkululeko Madondo. This is your Physical Sciences grade 11 class. Thank you guys so much. There's my email address, tcgt@gmail.com. If you have any further questions or you'd like me to send something to you, please, guys, do not hesitate. Just send me a chat and I will try my best. Thank you guys so much for a beautiful lesson and goodbye.